31.2 The soil. By the end of this section, you will be able to do the following. Describe how soils are formed. Explain soil composition. Describe a soil profile. Plants obtain inorganic elements from the soil, which serves as a natural medium for land plants. Soil is the outer loose layer that covers the surface of Earth. Soil quality is a major determinant, along with climate, of plant distribution and growth. Soil quality depends not only on the chemical composition of the soil, but also the topography, regional surface features, and the presence of living organisms. In agriculture, the history of the soil, such as the cultivating practices and previous crops, modify the characteristics and fertility of that soil. Soil develops very slowly over long periods of time, and its formation results from natural and environmental forces acting on mineral, rock, and organic compounds. Soils can be divided into two groups. Organic soils are those that are formed from sedimentation and primarily composed of organic matter, while those that are formed from the weathering of rocks and are primarily composed of inorganic material are called mineral soils. Mineral soils are predominant in terrestrial ecosystems, where soils may be covered by water for part of the year or exposed to the atmosphere. Everyday connection. Hydroponics. Figure 31.5 Plant physiologist Ray Wheeler checks onions being grown using hydroponic techniques. The other plants are Bibb lettuce, left, and radishes, right. Credit. NASA. Hydroponics is a method of growing plants in a water nutrient solution instead of soil. Since its advent, hydroponics has developed into a growing process that researchers often use. Scientists who are interested in studying plant nutrient deficiencies can use hydroponics to study the effects of different nutrient combinations under strictly controlled conditions. Hydroponics has also developed as a way to grow flowers, vegetables, and other crops in greenhouse environments. You might find hydroponically grown produce at your local grocery store. Today, many lettuces and tomatoes in your market have been hydroponically grown. 31.2 The soil. 875 Soil composition. Soil consists of these major components. Figure 31.6 Inorganic mineral matter, about 40 to 45% of the soil volume; organic matter, about 5% of the soil volume; water and air, about 50% of the soil volume. The amount of each of the four major components of soil depends on the amount of vegetation, soil compaction, and water present in the soil. A good healthy soil has sufficient air, water, minerals, and organic material to promote and sustain plant life. Visual connection. Figure 31.6 The four major components of soil are shown: inorganic minerals, organic matter, water, and air. Soil compaction can result when soil is compressed by heavy machinery or even foot traffic. How might this compaction change the soil composition? The organic material of soil, called humus, is made up of microorganisms, dead and alive, and dead animals and plants in varying stages of decay. Humus improves soil structure and provides plants with water and minerals. The inorganic material of soil consists of rock, slowly broken down into smaller particles that vary in size. Soil particles that are 0.1 to 2 mm in diameter are sand. Soil particles between 0.002 and 0.1 mm are called silt, and even smaller particles, less than 0.002 mm in diameter, are called clay. Some soils have no dominant particle size and contain a mixture of sand, silt, and humus. These soils are called loams. Link to learning. Explore this interactive map. http://openstax.org/l/soil_survey_map from the USDA's National Cooperative Soil Survey to access soil data for almost any region in the United States. Soil formation. Soil formation is the consequence of a combination of biological, physical, and chemical processes. Soil should ideally contain 50% solid material and 50% pore space. About one-half of the pore space should contain water, and the other half should contain air. The organic component of soil serves as a cementing agent, returns nutrients to the plant, allows soil to store moisture, makes soil tillable for farming, and provides energy for soil microorganisms. Most soil microorganisms, bacteria, algae, or fungi, are dormant in dry soil, but become active once moisture is available. 876 Chapter 31 Soil and Plant Nutrition. Access for free at openstax.org. Soil distribution is not homogeneous because its formation results in the production of layers, Together, the vertical section of a soil is called the soil profile. Within the soil profile, soil scientists define zones called horizons. A horizon is a soil layer with distinct physical and chemical properties that differ from those of other layers. 5 factors account for soil formation: parent material, climate, topography, biological factors, and time. Parent material: the organic and inorganic material in which soils form is the parent material. Mineral soils form directly from the weathering of bedrock, the solid rock that lies beneath the soil, and therefore, they have a similar composition to the original rock. Other soils form in materials that came from elsewhere, such as sand and glacial drift. Materials located in the depth of the soil are relatively unchanged compared with the deposited material. Sediments in rivers may have different characteristics, depending on whether the stream moves quickly or slowly. A fast-moving river could have sediments of rocks and sand, whereas a slow-moving river could have fine textured material, such as clay. Climate: temperature, moisture, and wind cause different patterns of weathering and therefore affect soil characteristics. The presence of moisture and nutrients from weathering will also promote biological activity, a key component of a quality soil. Topography. Regional surface features, familiarly called the lay of the land, can have a major influence on the characteristics and fertility of a soil. Topography affects water runoff, which strips away parent material and affects plant growth. Steep soils are more prone to erosion and may be thinner than soils that are relatively flat or level. Biological factors: the presence of living organisms greatly affects soil formation and structure. Animals and microorganisms can produce pores and crevices, and plant roots can penetrate into crevices to produce more fragmentation. Plant secretions promote the development of microorganisms around the root, in an area known as the rhizosphere. Additionally, leaves and other material that fall from plants decompose and contribute to soil composition. Time is an important factor in soil formation because soils develop over long periods. Soil formation is a dynamic process. Materials are deposited over time, decompose, and transform into other materials that can be used by living organisms or deposited onto the surface of the soil. Physical properties of the soil: soils are named and classified based on their horizons. The soil profile has 4 distinct layers. 1. O horizon. 2. A horizon. 3. B horizon, or subsoil. And 4. C horizon, or soil base, figure 31.7. The O horizon has freshly decomposing organic matter, humus, at its surface, with decomposed vegetation at its base. Humus enriches the soil with nutrients and enhances soil moisture retention. Topsoil. The top layer of soil is usually 2 to 3 inches deep, but this depth can vary considerably. For instance, river deltas like the Mississippi River Delta have deep layers of topsoil. Topsoil is rich in organic material. Microbial processes occur there, and it is the workhorse of plant production. The A horizon consists of a mixture of organic material with inorganic products of weathering, and it is therefore the beginning of true mineral soil. This horizon is typically darkly colored because of the presence of organic matter. In this area, rainwater percolates through the soil and carries materials from the surface. The B horizon is an accumulation of mostly fine material that has moved downward, resulting in a dense layer in the soil. In some soils, the B horizon contains nodules or a layer of calcium carbonate. The C horizon, or soil base, includes the parent material, plus the organic and inorganic material that is broken down to form soil. The parent material may be either created in its natural place, or transported from elsewhere to its present location. Beneath the C horizon lies bedrock. 31.2. The soil 877 Visual connection figure 31.7. This soil profile shows the different soil layers, O horizon, A horizon, B horizon, and C horizon, found in typical soils. Credit. Modification of work by USDA. Which horizon is considered the topsoil, and which is considered the subsoil. Some soils may have additional layers, or lack one of these layers. The thickness of the layers is also variable, and depends on the factors that influence soil formation. In general, immature soils may have O, A, and C horizons, whereas mature soils may display all of these, plus additional layers, figure 31.8. Figure 31.8. The San Joaquin soil profile has an O horizon, A horizon, B horizon, and C horizon. Credit. Modification of work by USDA, 878 Chapter 31, Soil and Plant Nutrition access for free at openstax.org. Career connection. Soil scientist. A soil scientist studies the biological components, physical and chemical properties, distribution, formation, and morphology of soils. Soil scientists need to have a strong background in physical and life sciences, plus a foundation in mathematics. They may work for federal or state agencies, academia, or the private sector. Their work may involve collecting data, carrying out research, interpreting results, inspecting soils, conducting soil surveys, and recommending soil management programs. Figure 31.9. This soil scientist is studying the horizons and composition of soil at a research site. Credit. USDA. Many soil scientists work both in an office and in the field. According to the United States Department of Agriculture, USDA, a soil scientist needs good observation skills to analyze and determine the characteristics of different types of soils. Soil types are complex and the geographical areas a soil scientist may survey are varied. Aerial photos or various satellite images are often used to research the areas. Computer skills and geographic information systems, GIS, help the scientist to analyze the multiple facets of geomorphology, topography, vegetation, and climate to discover the patterns left on the landscape. Soil scientists play a key role in understanding the soil's past, analyzing present conditions, and making recommendations for future soil-related practices.